Good day, students. Today I want to solve a problem that involves equilibrium of three forces acting at a point, which is triangle of forces. What is the principle of triangle of forces? It states that if three forces are acting in equilibrium, they can be represented in magnitude and direction by the three sides of a triangle taken in order. Now, what you are trying to say is that when you have this type of diagram, you have a force P, force Q, moving in different direction. You have the resultant, equilibrium moving opposite direction to the resultant. You see, if, for example, if the resultant is 2 Newton, the equilibrium which is opposite to this resultant will just be minus 2 Newton. You introduce negative sign. You can see we are bringing it to triangle of forces. You can see the P, the arrow moving in the eastern direction. From there, another force Q pick from where P stops because it's moving upward. You take it from there upward while the equilibrium is moving downward. From there, the arrow point is held to O. Yeah, okay? The arrow moving like this, moving like this, moving like this, bringing them together to triangle of forces. Now, let's solve this problem. A mass of 2 kilograms is supported by two chords. You can see the chords PQ, which makes angle 30 degree and 50 degree with a vertical as shown below. Calculate tension in the two chords. You can see the two chords, first chord, second chord. You want to bring it into triangle of forces. You can see that we have the 2 kilogram, which is corresponding to 20 Newton. How do you get 20 Newton? You know that weight equals to mass times acceleration due to gravity, and the mass is 2 kilogram times 10, which is acceleration due to gravity, which is 20 Newton. You convert to 20 Newton because tensions are in Newton. The unit of tension is in Newton, which is the same thing with weight. We have to see what you can do so that everything will be in the same unit. Now, the weight is acting downward. You bring the arrow downward, put 20 Newton. Okay, you can see this one moving upward to the vertical side, and this is the weight which is representing this is picking this line moving upward. You can see the arrow going up. Take it up, represent with Q. Now this angle is making angle 50 degree with the vertical, and this is a vertical also, making angle, the Q is making angle 50 degree with the vertical. P is moving upward to the vertical vertical line. Now it now pick from here to the vertical line. The arrow goes up. You can see arrow moving up. This one will now be 30 degree. You can represent this to be C, capital letter C, angle C. You need to get that. This triangle of forces. This is capital Q, while this one will be small letter P. This one will be capital P. To know this sum of angles in a triangle, that's angle Q plus angle P plus angle C equals to 180 degree. What is the reason? Sum of angles in a triangle give us that. Now what's angle P? That's angle Q 30 degree, angle P 50 degree plus angle C equals 180 degree. That's 80 degree plus angle C equals 180 degree. Collect the like terms. Angle C equals 180 degree minus 80 degree equals 100 degree. See, when you are with your four-figure table, you might not get 100 degrees centigrade. 100 degrees, sorry, you might not be able to get 100 degree, but you can, from your calculator, you can get the value. But because of those that we use four-figure table in WAEC, I will show you how to get that. You can have, when you have cast like this, cast, sine, cos, and tan. All of them are positive in the first quadrant, and ranging from 0 to 90 degrees. That means all of them within this range of angles, they are positive. but here is only sine that is cos. Sine is positive, cos is negative, and tan is negative. Here we have, and it ranges from 90 to 180 degree. This is the second quadrant. The third quadrant, we have sine positive, sine negative. Sine is negative sine, cos is negative, and tan is positive. That's why you have capital T. This is a third quadrant ranging from 180 degree to 270 degree. The fourth quadrant, you have cos to be positive, sine negative, cos positive, and tan negative. It ranges from 270 degree to 360 degree. Is it? And in this case, you want to know where the 100 degree fall. It fall within this range. When you want to get sine 100 degree in your four-figure table, you just do sine 180 degree minus, because this is the highest, minus 100, which is sine 80 degree. If you press your calculator, sine 100 degree and sine 80 degree, they are the same. You can get this one in your four-figure table, but you cannot get sine 100 in your four-figure table. Because of the four-figure table, you can easily get this. You're going to convert it to this so that you get used to how to use quadrants. Now let's now see. We want to use sine rule to get the tension. Let's call this one T1, tension 1, and tension 2. Using sine rule. Using sine rule. Okay, in that case, since you are using sine rule, we now have sine. This one will be this 100 now, 100 degree. This one is there in the diagram. We are going to be using it, combining it with either T1 or T2. Okay, now you now have sine Q over small letter q equals to sine C over small letter c. Okay, small letter c. What is sine q? Sine q is 30 degree. Sine 30 degree equal over q, which is T1, equals sine C, sine 100 over C 20. Now you cross multiply. You can still just change it to this. Sine 30 degree over T1 equal to sine 80 degree. You have done that over 20. Cross multiply. T1 sine 80 degree equals 20 sine 30 degree. Divide both sides by sine 80 degree, divided by sine 80 degree. Cancel each other. T1 equals 20 times sine 30 degree 0.5 divided by sine 80. We check your four-figure table or press your calculator. 0.9848. When you press your calculator, you have 10 divided by 0.9848. T1, therefore T1 equals 10.15 Newton. This one T1 Q. The tension, the first tension. Let's get the second tension. The second tension, you still use sine rule, which is sine P over small letter p equals sine C over small letter c over what's our p? That's T2 equals sine C over c, which is 20. Now sine 50 degree equals sine 80. We have done that here, equivalent to sine 100 over 20. That's T2, cross multiply. T2 sine 80 degree equals 20 sine 50 degree. Divide both sides by sine 80 degree. Divide by sine 80 degree. Cancel each other. T2 equals 20 times what sine 50 degree, which is 0.7660 divided by sine 80 is 0.9848. Okay, now T2 equals, when you multiply that, you have 15.32 divided by 0.9848. Therefore, T2 equals 15. Therefore T2 equals 15.56 Newton. This is the second tension, 15.56 Newton. This is the end of our class. Please subscribe to my channel so that I can have access to the latest video. Have a wonderful day.